This is 6.5, day 2, part 2. We're going on to graph this quartic function. So go ahead and write the example down. F of x equals x to the fourth minus 9x squared plus 18. And we're going to identify in part A the pieces. First, we'll identify the degree. The degree is 4. So that tells me that I have either the shape of a W or an M. And we'll identify which one in just a little bit. And then we talk about the end behavior. The end behavior is found by the leading coefficient test. The leading coefficient is positive. The degree n is even. So from our chart, it's just like a leading coefficient of a quadratic where it opens up. So that means I have right-hand behavior. It rises on the right and rises on the left. So if I look at the W or the M, which one does that? This one is an M and we fall on both sides. So the shape is going to look like a W. So then let's go on and identify the name of this polynomial. The name of this polynomial first is the degree is 4. So we call this a quartic. And then we count up how many terms there are. There are 3 terms. So this is called a quartic trinomial. Now let's go down in part B and find the x-intercepts. Remember, to find the x-intercepts, we set the function equal to 0 and we solve for x. We're finding the zeros of the function. So 0 equals x to the fourth minus 9x squared plus 18. So we have to factor this. There's 3 terms, but notice the degree. The degree is to the x to the fourth power. So it's very close to the chart method where we say 0 equals, and we split up the x to the fourth into x squared and x squared. Then let's make our chart over here. And we say, what are the factors of C, so 18, that add to B, which is negative 9. So we look for different multipliers of 18. Well, negative 6 times negative 3 adds to negative 9. So the numbers we work with are the negative 6 and the negative 3. They go right here and right there. So now we have this factored out, and now we use the zero product property and set those factors equal to 0 and solve for x. Remember, if you have a 4th degree polynomial, you have up to 4 zeros in the function. So I set x squared minus 6 equal to 0, and then x squared minus 3 equal to 0. Now I undo it, so I add 6, and then I square root it. Don't forget the plus and minus in front of 6, the square root of 6. You'll want to use a calculator to now answer what that question is so we can graph it later as an x-intercept. So the square root of 6 is approximately 2.4, plus or minus 2.4, so very close to 5. So let's just go 2.5. Then we go over to the second equation, we do the same thing. Add 3. That's undoing the minus 3. Then we undo the squared, we square root it. Don't forget the plus and the minus. Now we square root plus or minus 3, which x is approximately plus or minus 1.7. Do make sure you can do those with your calculator. So now we're going to identify in part C the y-intercept. Remember, to find the y-intercept when it's in standard form, it is the constant of the equation. So if we go up to the constant, that constant is 18. And you got to take the sign with it. So that constant is 18. So we have a y-intercept at 0, 18. The next piece is start to graph the things that you have and then find a couple additional points. So I'll give you some time to go ahead and create an XY plane. Our units is, I'd probably say by 2 in order to get that y-intercept to be 18. Okay, so let's go ahead and start to graph these pieces. So this is my x-axis, this is my y-axis, and I said let's go by 2's on especially the y-axis. So this would represent 2, 4, 6, 8, 10, 12, 14, 16, 18. So we have a y-intercept at over 0 up 18. So there's our first point to graph. Then we have 4 x-intercepts. So we want to identify those x-intercepts as ordered pairs. So we have an ordered pair at over 2.5, comma 0, and negative 2.5, comma 0. So let's graph those next. So we'll graph those in green. You don't have to change your x-axis if you don't want to. You could scale it by 1. Or in this case, we're pretty scrunched up, so I'm going to scale this 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So it's not so tight together. And then we have 2.5, so over 2.5 up 0. And then left 2.5 up 0. So let's label those points, 2.5, comma 0, negative 2.5, comma 0. And then I have these other set of x-intercepts at approximately 1.7, comma 0, and negative 1.7, comma 0. So these points are at over 1.7, so about here, and about there. Okay, so we've identified the y-intercept and the 4 x-intercepts. Now we're going to identify that end behavior that helped us, the leading coefficient test. The leading coefficient test identifies the end of both x-intercepts. So the end behavior was rising on the right and rising on the left. So I go out to the farthest intercepts. So I have an intercept here, so I know that last point has to rise, and this last point has to rise. I can't go back down because I have up to 4 x-intercepts. And then I remember the shape. The shape has to be a W, something like that. Well, we've covered now this piece and this piece. You'll probably start to recognize what will happen next. I'm going to just approximate that this has to come down. And then what do you think happens between negative 1.7 and 0 is it's going to go up and then come back down and then go below and back up. So in this question, you most likely don't even have to substitute any values in for additional points. But if you're a little bit nervous, maybe go ahead and substitute -1 or 7 into the function. So if you wanted to evaluate for f of 1 to make sure that that is a point above the x-axis, so you say 1 to the 4th minus 9, 1 squared plus 18. Well, 1 times 1 times 1 times 1 is 1, minus, this has to be 1, squared is 1, and then 1 minus 9 plus 18, 1 minus 9 is -8, plus 18 is 10. So what we have is an ordered pair over 1 up 10. So here is my over 1 up 10. Yep, we're very close there. And then there's symmetry on this side also, so you'd have another one. So that finishes that problem of graphing all the pieces. I'll stop the recording there.